G'day, this is just a funny video. I've been thinking about kind of an idea for running Unix domain sockets over RDMA. So I just want to record it and get it out there and get some feedback from some people. So often in a Kubernetes cluster, you might run a set of nodes and you run the similar workload on them all, right? So you'll have producers that are all running, might be Golang or something, producing into a cluster of Red Panda Kafka, and then that would be feeding ClickHouse, and they're all co-located on the same machines. And so for a lot of the traffic, you don't really need TCP, right? Because you're just going from one container directly to the next. Why bother with all the complication of TCP and QDisks and all of the locks and all that stuff, right? So it looks like this today, TCP everywhere, right? But you could potentially just do Unix domain sockets between the processes on the same machine. Doesn't help you. You still need to connect to the other machines via TCP, but at least for the traffic that is all on the same machine, it'd be a lot faster. I did send Red Panda a pull request for this, and the performance is definitely better. Lower latency, better in all measurements. But it's not that much of a win, right? Because it's only the local traffic. So if that client needs to talk to the other two nodes, obviously that's TCP. And then even within the Red Panda itself and within the ClickHouse itself, they've all got to replicate to each other, and that's all going to be TCP as well, right? So the win is small. But I've been looking at these ROCEv2 networks, right? So really the core concept here is the kernel bypass, that the packets land in the NIC and then they get copied straight up into the available memory in that pre-created buffer, right, via the Q pair. And so that's really cool, but you would have to, in the case of Red Panda or ClickHouse, you'd have to do a lot of work to write the code to get them to play nicely with all the RDMA libraries, right? So that's a big lift. That's hard. So I was wondering, and maybe, I don't know if this idea makes sense, but you could potentially get the kernel to do this. So this wouldn't be a complete kernel bypass, but it would be a bypass of the NIC driver, the QDisks, the like NF tables, and TCP, right? So you go around all of those problems. You could easily move memory from one machine to the other via RDMA into the kernel, and then you could potentially just have a Unix domain socket from the kernel into the userland app. And because there's a lot of userland apps that do support Unix domain sockets, this would be like a way to accelerate traffic between the nodes in the cluster, getting a lot of the benefits of the kernel bypass, but without full kernel bypass and not having to add RDMA to the app, right? And so you could take it a step further and you could actually do IOU rings. So for example, I noticed just recently that Red Panda are adding all the IOU ring stuff, right? So in that case, the app would be getting the memory buffer, it passes it into the kernel, you could have this kernel module register the Q pair and register the buffer, and so packets could come in, go straight into that buffer, into the IOU ring, and then return that up to the application, and you're done. Should be incredibly fast, I think. So that's the idea, and I don't think it'll be too hard to implement. So yeah, that's sort of the idea I'm wondering about.